Good evening, friends. Myself Ankush Gupta here at the Gate Coach, and today we are here to discuss the solutions of some of the questions which were remaining from my subject last time, that is chemical reaction engineering. So in CRE, if you guys remember, there were total 5 to 7 questions of total 12 marks. Okay, and the first question was question number 26, according to the PDF which all of you have from the official website. This was the first question. यहाँ रख दो. So I hope all of you know the answer of this question. The similar question they have asked in previous years as well. Okay, that time the option was n observed equal to n true plus 1 upon 2. This question was in 1998 or maybe 1999. Okay, so you can check that by yourself. Where there was a chemical reaction given and you have to calculate the correct Somalia. The correct answer will be 3 by 2 here, because in Thiele modulus, in heterogeneous reaction system, Thiele modulus is the most important topic, because if you see the previous year papers, most of the question they have asked from the Thiele modulus. Okay, so in Thiele modulus, there are different cases when Thiele modulus is greater than 4. It is the case of strong pore diffusion resistance design, where ultimately we will get n observed equal to n true plus 1 upon 2. So here in the reaction order is given 2. So the observed order will become 2 plus 1 upon 2, that is 3 by 2. Okay. We have already uploaded the video of heterogeneous reaction system as well. And in the revision classes as well, we discussed about the Thiele modulus and these two cases. Similarly, there was a question in 2006 or maybe 2007 where you have to calculate the observed activation energy. The other part of this question, which will be E true upon 2 for strong pore diffusion resistance design, if you remember the question. Okay. So yeah, this was one of the question which they have asked previously as well. Now after that, there was a question from enzyme reaction, this one, and here the correct answer will be option A. If you follow our channel, then you must have figured out that there was a video on the enzyme kinetics we have uploaded last year itself when this topic was introduced, and there we discussed about the Michaelis-Menten equation as well as LB plot, that is Lineweaver-Burke plot. Okay, here the only difference was they produced the inhibitor in the reaction system, in the enzyme reaction system. So after that, they are asking what will be the correct profile. Basically, if you see, all these are double reciprocal plots only, LB plots. Okay, so how can we solve this question? I will not go in much details because the video of this particular topic is already on our channel, which you can watch. We will update the link of the video in the description later on. Okay. So enzyme reaction kinetics, if you know the Michaelis-Menten equation, that was V naught is equal to V max concentration of substrate S over Km, that is Michaelis-Menten constant, plus S. where V naught is the velocity of the reaction, or you can say rate of the reaction, doesn't matter. Vmax is the maximum rate of the reaction or velocity of the reaction. So if you take the reciprocal of this equation, it will become 1 over V naught equal to Km plus S, concentration of S, divided by Vmax into concentration of X, which you can also write it as Km over Vmax into 1 upon concentration of S plus 1 upon Vmax. And here if you see at this equation, it is in the form of y equal to mx plus c, which will give us the double reciprocal plot. Double reciprocal plot, also known as Lineweaver Burke plot. In short, LB plot. So if you just type LB plot on the Google, okay, you will get this, the answer of this question. So here on y-axis we will be having 1 over V naught. On x-axis we will be having 1 upon concentration of S. And this will be a straight line where you can see the intercept on y-axis will be 1 upon Vmax, and the slope of this line will be Km over Vmax. This is the plot which we have, which we will get from this expression. Now further, if you go on the minus x-axis from the origin and extend this curve here, then for 1 upon s equal to 0, sorry, not 1 upon s equal to 0, for intercept, intercept on y-axis equal to 0, you can see the equation will become 1 upon V naught equal to, this is the equation, let me write it for you again. This is the expression. So if I talk about this particular point, so you can see on this point, this intercept will become 0 as we are here. This value will become 0 and you will get the value of 1 by s equal to km. The intercept 0, ये थोड़ी 0 होगा. Sorry, what I am saying. Here at this point, 1 upon V naught will become 0. So when you will rearrange this, you will get minus of 1 upon, sorry. Actually, we are not used to write like this. So you will get minus 1 upon s equal to km. Okay, because 1 upon V naught will become 0. So at this point, this value will be km, which is Michaelis-Menten constant. Okay, that you can say the intercept on x-axis. This value is the intercept on x-axis. This 1 by Vmax is the intercept on y-axis. So this is the LB plot. Okay. Now if you look at the question, they are saying, where is the question? This one. This is the question, guys. So you can see the inhibitor which we are introducing in the reaction system is competing with the substrate. Okay, is competing with the substrate, that is the reactant for us. So what happens now when we talk about the reactant, which is when we talk about the inhibitor which competes with the reactant, the substrate. There are actually three cases. When we introduce the inhibitor in the reaction system, there are three possible cases we get. Either the inhibitor will compete with the substrate, and that is called the competitive inhibitor, or it will be uncompetitive inhibitor, it will not compete, or otherwise it will be non-competitive inhibitor, means the mixed one. So what happens when we introduce the inhibitor, and if it is a competitive inhibitor, I hope you understand, you know the theory of this part. Okay, what is competitive inhibitor, what is non-competitive, and what is uncompetitive. So we will not go into that case because we are here for the solution, not for the discussion of the topic. For that, if you wish, we can make a separate video. But here, anyways, for competitive inhibitors, what they do, competitive inhibitors affects the Michaelis-Menten constant. Okay, they increases the value of Km and the value of Vmax, the parameter, the maximum velocity remains constant in this case. Okay, so when they increases the value of Km, what happens? If you look at the curve, what was the LB plot? If you remember here, when there was no inhibitor, only the substrate, the curve was something like this. We can say this was the curve. Okay, when inhibitor was absent. But when you introduce the competitive inhibitor, it does not affect the Vmax. Okay, no problem, but it increases the value of Km. So when it will increases the value of Km, what will happen? You can see this intercept. If Km increases, it will go on this side because this is minus value, so it will go on this side. Plus the slope. Vmax is constant, so the slope will increase. So the curve will become something like this. When inhibitor is present. Okay, that was the only thing they were asking. Okay, if we increase the competitive inhibitor, what will happen? This will be the curve. That is option A, if you guys remember in the question. So that is the answer. And this question was there for 1 mark, I guess. Okay, simple question. This one from enzyme reaction kinetics. Okay, as you can see. Option A, curve with increasing inhibitor. This is the curve. Slope has been increased. Simple. So this is the answer. I hope it is clear to all of you. And when we have uncompetitive inhibitor, what does it do? It decreases the Km and it also decreases the Vmax. And the best thing is it decreases both of them in same amount. Which means the ratio of Km over Vmax will remain constant. Okay. So that means if you talk about the LB plot between 1 over V naught and 1 over S naught, so not S naught, 1 over SES, concentration of S. So before the inhibitor, it was the curve, and after the inhibitor, This will be the curve. It will remain parallel. The slope will remain parallel. Okay. And as Km has decreased, so this was the point before the inhibitor, and so Km will go on left hand side further here. Okay, like this. So Km will decrease, but slope curve will remain parallel because the slope will remain constant. This is the nature of uncommutative inhibitor. And when we talk about the non-competitive inhibitor, so in that case, what happens? This value Km will remain constant. Okay, this value Km will remain constant, and the value of Vmax will decrease. Okay, so here you can see in the curve, this was the curve initially when there was no inhibitor, when it was absent, when it was present. Absent and present. So when Km remains constant, so the in origin point will remain same. That's not a that is clear. The intercept on x-axis will remain same. Okay, but when what will happen to Vmax? See, if Vmax decreases, this overall slope will increase. So the curve will be like this when it is present. So this is all about the question number 27. Okay, so I hope it is clear to all of you, and it was, that's how you can answer this question. Simple. Km Vmax. So you should know what does competitive or uncompetitive or non-competitive inhibitor do, and how they affect the main parameters. Michaelis maintain constant and the maximum velocity of the reaction. Okay, so that's how you can answer this question. Now after that, all other questions I hope you must have solved. Like there was a question on segregation model. Okay, and if you guys remember, the segregation model, that is not in your syllabus. If you see the syllabus, it is not mentioned that you have to study segregation model, because in non-ideal reactor there are three types of models: zero parameter, one parameter, and two parameter model. In your syllabus they have mentioned only one parameter model, but if you look at the exam previous year questions, they have asked the question on segregation model multiple occasions. First they asked the question on segregation model in year 2000. Okay, and then there was a question in year 2019, and now there is a question in year 2022. So according to segregation model, which is one of the zero parameter model in non-ideal reactor, mean conversion we can calculate by using this expression, where zero is the time after which tracer start to leave the reactor, and infinite is the time till which all the tracer molecules has left the reactor. If you guys remember the pulse input method, RTD experiment, so here this value will remain 0, but this value will become 0.5, because at 0.5 this curve is ending, all the molecules are leaving, there is no dead zone, there is no left tail, long tail. So this is 0.5. Here if you see, this is elementary reaction 2pq. So minus Rp for this reaction will be Kcp square. And for this type of reactions, second order reaction conversion, we know that can be calculated by the kinetic expression, which is this. If you know the kinetic equation for second order reaction. So here K is given 2, Ca naught is given 2. So this value will become 40 upon 1 plus 40. Okay. Now you have to find out Et in terms of time. That is absolutely easy. So all of us know that the area of E curve in the total time interval, the curve will always be 1. Okay. So area of the E curve will always be 1. So if you break this curve in two parts, so you can see this is the rectangle and this is the triangle. And what is the area of rectangle here? Base into height, that is 0.5 into 1, plus area of triangle, that is half into base into height. So half into base, that is 0.5 into height. What is height? Let's say this is EM. So height will be this much height. That is EM minus, EM is this total, minus 1. On solving this, you will get EM equal to 3. Okay, so here if you look at this curve, this is a straight line equation with one constant slope. And for a straight line equation connecting the 2 points, we know the equation of a straight line connecting the 2 points can be calculated by this method. Okay, so here let's say this is x1 y1, which is 0 comma 1. This is x2 y2, which is 0.5 comma 3. So when you will solve, you will get ET equal to 40 plus 1. Okay, you can put the values and solve. Y will become ET, X will become T. I hope you do understand this. So when you put those values here in this expression, XA bar will be integration from 0 to 0.5 of 40 into dt, because 1 plus 40 will get cancelled and this will be equal to 0.5. That means 50% is. So this is segregation model, 2 marks question, very easy. And this time this is not lengthy as well. Last time it was quite lengthy because it was C curve was given and there was nothing was getting cancelled, but it is easy. So this is easy question for 2 marks and simple one. Okay. Now there was a question 64. This was a lengthy question. Okay. And I hope all of you have solved this question. The answer for this question is 47.46. To 1 decimal places, we can say 47.5 kilojoule per mole. So what you have to do, if you look at the question, in first case PFR is given, in second case MFR is given. Here in PFR, Ca0 is given as, Ca0 is not given, sorry, other data. Pure A is going in the system, so Ya0 will become 1. Tau, which is V by V0, volume of the reactor is 10 meter cube, volumetric flow rate is given 5 meter cube per hour, so it will be 2 hours. Okay, and the reaction is A gives B plus C. This is a gaseous reaction where overall stoichiometric coefficient is equal to 1. So it is obvious that it will follow variable volume reaction system kinetics. So for PFR, undergoing having a variable volume reaction system, the design equation is given as tau equal to Ca0 from 0 to xa dxa over minus Ra, where if you put the value of minus Ra, that will be Kca. Here the temperature is 400 Kelvin. Okay. So for variable volume reaction system, we know that Ca can be written as Ca0 1 minus Xa over 1 plus epsilon A Xa, and dxa is there. So I hope you know how to calculate epsilon A, that is delta into Ya0. For this case, it will be 1. Ca naught will get cancelled. So the equation will become K is equal to 1 upon tau integration from 0 to xa 1 plus xa over 1 minus xa into dxa. So here you can put xa equal to 0.8 as given, tau is equal to 2 which you have calculated. So you will get K is equal to 1.2094. So I can say approximately 1.21 at 400 Kelvin. For MFR, it is given that 50% A is going in the system. So Ya naught will become 0.5. Thus, epsilon A will be 0.5. You can check by the same method, delta into Ya naught. And for MFR, the design equation is Ca naught into Xa over minus Ra, which will be equal to Kca. And you can write Ca as Ca naught, that will get cancelled, 1 plus epsilon A Xa over 1 minus Xa. This will be the equation. Okay. For MFR as well, V and V naught are same, so tau will be equal to 2 hours. So you can put the values here, and when you will put the values and solve, epsilon A is 0.5, Xa is 0.8, tau is 2, you will get K is equal to 2.8 R inverse at the rate 425 Kelvin, because for MFR temperature is 425 Kelvin. Now when you have K at T1, K at T2, you can use the Arrhenius theory, because we know that whenever we have to talk about the activation energy, rate constants and temperature, if nothing has mentioned, by default we will go with the Arrhenius theory. And here when you will use the Arrhenius theory, that is ln of K2 by K1 equal to E by R 1 over T1 minus 1 over T2. So on putting the values and rearranging the equation, you will get 47.5 kilojoule per mole, your answer. टेक्निकल स्टूडेंट, अरे सर प्रमोशन करो मेरे चैनल का। भाई अपना नाम तो बता दो, मैं आपको जानता भी नहीं, ऐसे कैसे प्रमोशन कर दूं। अब मैं कोई सेलिब्रिटी थोड़ी हूँ, सेलिब्रिटी हायर करो अपने प्रमोशन के लिए जैसे पूरी दुनिया करती है। एनीवेज, आई होप इट इज क्लियर टू ऑल ऑफ यू गाइस। Now this question was there, MFPFR with recycle stream. So we know that when recycle ratio will be 0, this will be simply ideal PFR, where the conversion is given 50%. And when will this R will tends to infinite, this PFR with recycle stream act as an ideal MFR. Okay, and the design equation of PFR with recycle stream is V by V naught equal to R plus 1 times of Ca naught integration from Xa1 to Xa2 dxa over minus Ra. This is the design equation for PFR with recycle stream. But the point is, for R equal to infinite, we cannot use this equation because it will be difficult to solve. Okay, so what we have to do? We know that this system will act as an ideal MFR. So what is the meaning of this line? The meaning is PFR with infinite recycle will act as an ideal MFR. That means both the systems will form same result. Both the systems, PFR with infinite recycle and ideal MFR, both of them for the given inputs, they will produce same results. So it means I can use the design equation of ideal MFR to to calculate this conversion. Okay, so for PFR design equation, this here liquid phase reaction is given. Sorry, minus Ra is equal to KCa square, and Ca can be written as Ca naught 1 minus Xa. So when you will put this value and rearrange, you will get tau is equal to 1 by K Xa over 1 minus Xa. Here you can put Xa equal to 0.5, so you will get tau K equal to 1. Okay. Now if I talk about the MFR, for MFR the design equation is tau equal to Ca naught Xa over minus Ra, which is equal to KCa square. For constant volume reaction system, liquid phase reaction, Ca equal to Ca naught 1 minus Xa. So this K will go on the left hand side, it will remain, equation will become here Ca naught will be there, 1 upon Ca naught. Tau K will be equal to 1 by Ca naught. Ca naught will remain 1 Ca naught, as this is Ca is not a square. So 1 Ca naught will be there. So Ca naught is given 2, so this value will be 1 by 2. Or even if you don't put the value, you can say tau K Ca naught equal to 1. Okay, that is the Dam-Collar number for second order reaction. So similarly here, when I talk about the MFR, it will be like this equation. I hope you know this. So tau K Ca naught, Dam-Collar number of second order. As Ca naught is same, K is same, tau is same, so Dam-Collar number will remain same. So this value will be equal to 1, and when you will rearrange this expression, you will get Xa square minus 3Xa plus 1 equal to 0, and on solving this you will get Xa equal to 0.3819 up to 2 decimal places. In percentage you can say 38.2%. I hope it is clear to all of you. Okay, that's how you can solve. But remember, we cannot use directly MFI equation. We should know the reason why we are using it. Okay, because PFR with infinite recycle will produce the same result which ideal MFR is producing. That is the reason. Since it is difficult to calculate this expression. That's why we are going for equation of ideal MFR. Okay, I hope this part is also clear to all of you. Now the next question, this one. So I hope you have read this question. Consider the process in the figure. This is the figure. Liquid phase elementary reactions are given like this. Occurs in Cstr where mole fractions are given. K1, K2 equal to K3 is given. All streams, process feed, process exit, and recycle streams are pure. Except the reactor outlet, every other stream is pure stream. So this is fresh B, this is fresh A, this is recycle A, this is unreacted B, product P, recycle S. Now it is given that let's say Q is some parameter which is equal to XA upon XB. And all these mole fractions are within the reactor as mentioned. Xj is the mole fraction of component J in the CSTR. But we know that for CSTR there is a characteristic that concentration within the reactor and at the outlet remains same. So we can say these are the mole fractions at the reactor outlet as well here at this point. Now it is given that the generation of product S, undesired product S in the CSTR is 0. So that means at a steady state, if you look at this expression, so rate of formation of S will be equal to rate of disappearance of S. Okay, and rate of formation of S we can get from the second reaction, which is equal to K2 XP XB. K2 XP XB, that is equal to rate of disappearance of S, which we can get from step 3, that is K3 XS XA. So K2 and K3 as given, they are equal, so it will get cancelled out and we will left with XP upon XS is equal to XA upon XB, which is nothing but Q as given. And if you guys remember, then the mole ratio of mole fraction is also equal to ratio of moles. So that means here I can also say the moles of, or actually the molar flow rate of P divided by molar flow rate of S will be equal to moles of molar flow rate of A divided by molar flow rate of B, that is Q. Why? Because mole fraction of P means moles of P divided by total moles. Mole fraction of S means moles of S divided by total moles. Total moles will get cancelled. We are left with mole ratio. So I hope you can understand this. So here, if you look at this expression Fp upon Fs, they are saying S is the undesired product. So it means P is the desired product. So P upon S you have to calculate at the reactor outlet. That's what they are asking. For which value of Q the molar flow rate of A and S in the recycle stream will be minimized. So molar flow rate of A in the recycle stream, let's say FAR. Molar flow rate of S in the recycle stream, let's say FSR. So their sum FAR plus FSR will be minimum. They are saying. And if it will be minimum, so it will be constant as well. Okay. So that is the selectivity, we can say. The selectivity. Selectivity. Now if you look at this process, this is at a steady state. B is going in, A is going in. Here pure A is coming in the recycle. So in the MFR, if you see the reactor inlet, A will be equal to A coming from the fresh feed, FA naught, plus A coming from the recycle stream, let's say FAR. B will be equal to whatever B is coming from the fresh feed, let's say FB naught. And S will also be the inlet, which is coming from the recycle reactor stream, FSR. Okay. Now it is given that 90% of the B is there in the reactor. In the reactor, we have 90% conversion of B. So that means if you go at the reactor outlet, B will be equal to whatever B is going in the reactor, 90% is reacting and 10% is unreacted. So B will be 0.1 FP naught. Amount of P, if you see the reaction, if you combine all these reactions, final reaction which you will get will be A plus B gives P. On combining all these steps, you will get this overall reaction. Okay. So here you can see 1 mole B react with 1 mole A to give 1 mole P. 1 mole B react with 1 mole A to give 1 mole P. If how much B has been reacted? amount of B reacted is equal to 0.9 times of FB naught. So whatever B is reacting, the same amount of P will form, and that will be 0.9 times of FB naught. Okay, S neither is going in, neither going out. So whatever S is recycling, that is already present in the system, because new S is not forming. So that means the amount of S here will remain constant. Remember this, because it is given the generation of S, the net generation of S in the reactor is 0. And we don't have any other place where S can be formed, only in the reactor. So if amount of S generating in the reactor is 0, so obviously this reaction, overall reaction, we can consider easily, and whatever S is there, it will remain constant. It will act as an inert overall. If you see the overall process, this S will is kind of an inert component which is not affecting anything. So its amount will remain constant because it is not participating in the reaction overall, if you see. Okay, although we know technically if S is participating in the reaction, the same amount is getting generated, so the net generation is 0. That's why it is constant anyways. So amount of S in the reactor outlet is equal to whatever S is recycling, the same is there in the reactor outlet, FSR. What is the amount of A here? That is equal to FAR, which we know. Whatever A is getting recycled, the same is coming from here. And what is this value, FAR? If you look at this expression, 1 mole B react with 1 mole A. So amount of A reacted, if I am not, don't write this directly. So I can say A is here equal to fed minus reacted. A in the outlet equal to A fed minus A reacted. What is A fed? A fed equal to this value minus A reacted equal to 0.9 times of FB naught. Okay, and whatever A we have here, the same amount is going in the recycle stream. So that means amount of A here is FA naught plus FAR minus 0.9 times of FB naught equal to amount of A getting recycled, that is FAR. So when you rearrange this expression, you will get FA naught equal to FA naught equal to 0.9 times of FB naught. Okay, it means if we are sending 10 moles of B, so 90% of this, 9 mole of A will be introduced in the system and 9 mole of P will produced. So amount of A, see, just try to understand, whatever amount of A we are introducing, the same amount is reacting overall. So conversion of A in the reactor is 100%. Conversion of A in the reactor is 100%. So that means whatever A is getting recycled, that is already present in the system. So amount of A in the reactor outlet will also be a constant value. Okay, that is FAR. So Q, that is XA upon XB. Here, what will be this value? You can calculate now. You know the value of all the streams, so put that value here and you will get to know that this value FSR and FAR are already constant. Okay, so for which value of A and mole fraction of A or mole fraction of B, here this ratio will become minimized. This sum will be minimum because since they are already constant, so for which value of A and B this ratio will be minimized. That will be possible only, see, whatever A is there, A we have in the reactor outlet, it is not coming from the inlet, because what the total amount of A which is going in the reactor inlet here from the fresh stream is participating in the reaction completely. So whatever A is get circulating, that is constant. Whatever S is getting circulated, that is constant. And when two values are already a constant, so nothing can minimize or maximize them. I hope you can understand. कितने मार्क्स पर 100 रैंक होगा, कोई आइडिया सर? So I hope this is clear, guys. Okay, if any one of you still have any doubt, so you can call us or mail us. We will discuss this particular topic in more detail. This particular topic is known as CSTR separator recycle. Okay, designing of CSTR separator and recycle systems. And this was not the first time they asked such question. If you see the previous year papers, earlier as well in 2019 maybe or 2020, they have asked the similar type of question. If you see the, if you have, if I can show you, yeah, this one. In year 2019, the same question they asked there as well. Okay. But this time, there it was single reaction, now it is multiple reaction. That's it. Which also you can write in the single reaction form. Anyways, so this is about the CRE questions, guys. I hope it is clear to all of you. Now, if still you have any doubt or anything regarding any specific question, so you can mention that particular question. We will upload the PDF of this question paper in the video description of this video as well. So based on that PDF, just mention the question number in the comment box. We will provide you the solution of that video as well. As all of us know that tomorrow your official answer key is coming, and lot of you are waiting for that, and some of you are not thinking about that because you will directly see the results. Okay, I can understand that because it depends on the mood. Sometimes we like to know the answers, we like to know the result before everything, so we do the efforts. That's why all of you are watching these videos and coming to the solution. And sometimes we don't care about all this stuff because we know whatever we have done, that is done, and it can't be changes. So leave it and keep our mind on break for some time, because we are doing the study from last 6 7 months 8 months 1 year. So एक ब्रेक तो बनता है, ये भी एक अच्छा पॉइंट है, कोई प्रॉब्लम नहीं है. तो हम सीधा रिजल्ट ही देखेंगे. बट मीन वाइल व्हाट यू गाइस कैन डू, focus on your next exam. Whatever result, whatever exam you have done, whatever things you have done in the exam, good or bad, doesn't matter. उससे कोई फर्क नहीं पड़ता. Remember, gate exam is just one exam, not a matter of life and death. सो गेट एग्जाम में आपका जो भी रिजल्ट आ रहा है, कोई फर्क नहीं पड़ता, वो आगे आएगा. अभी के मोमेंट पे उसे आप बदल नहीं सकते. जो भी आप करके आए हो, कर चुके हो, तो उससे अब कोई फर्क नहीं पड़ता उसके बारे में सोचने से. हाँ, आपका टाइम जरूर वेस्ट होगा. तो इसलिए अगर आपने अच्छा किया है तो खुश होने की जरूरत नहीं है, खराब किया है तो परेशान होने की जरूरत नहीं है. उसे बस एक एक्सपीरियंस समझो. बिकॉज आई नो ऑल ऑफ यू जिन्होंने काफी मेहनत की गेट एग्जाम में, ड्यू टू एनी रीजन कुछ गूफ गूफ अप्स कर दिए और एग्जाम में कुछ आपका एक्सपेक्टेड रिजल्ट नहीं आया या एक्सपेक्टेड परफॉर्मेंस नहीं आया, तो ऑब्वियसली जो भी मेहनत की है वो वेस्ट तो नहीं जाएगी. आप 23 में दोबारा कोई अटेम्प्ट दोगे उसके लिए, तो इससे बेटर है जो भी चीजें आज तक पढ़ी हैं उसका यूज करके अगले जो आपका गोल है, बार के एग्जाम या बाकी के जो आपके दूसरे एग्जाम्स है, एनआरएल का हो गया, आरसीएफएल के हो गए, एमआरपीएल या जो भी दूसरे एग्जाम्स हैं, उनके लिए आप अपनी प्रिपरेशन कर सकते हो, उस नॉलेज को यूज कर सकते हो. ठीक है, तो टाइम खराब करके, खुद को परेशान करके, खुद को खुश करके कुछ नहीं मिलेगा. जस्ट रिलैक्स एंड चिल. ओके, एंड फोकस ऑन द नेक्स्ट टारगेट. Okay, and that's all. See you guys. If you have any particular doubt or anything, or you want to know anything regarding the exam or what you can do after the gate exam or the exam analysis. So we will upload a video. We will be live on our YouTube channel again with the analysis video in this upcoming week. And till then, if you have any specific doubt, you can mention in the comment box, you can mail us, you can WhatsApp us, you can call us, or you can mention your doubt in the Telegram groups. Wherever you wish, you can, because we are everywhere on Twitter and Instagram as well. Okay, so see you guys. Take care. Bye bye. Data. bar के एग्जाम डायरेक्टली रिजल्ट. यस अंकित, दिस टाइप ऑफ क्वेश्चन डायरेक्ट रिजल्ट होते हैं. मतलब ऐसे क्वेश्चन आते हैं एग्जाम में जहां अगर आपको कॉन्सेप्ट पता है तो आप डायरेक्टली उसका आंसर कर सकते हो. जैसे केमिकल टेक्नोलॉजी के क्वेश्चन है, उसमें कोई आपको कैलकुलेशन या कुछ थ्योरी थोड़ी लिखनी है. आपको क्वेश्चन पता है, आंसर पता है, डायरेक्ट लिखो. तो ऐसे क्वेश्चन न्यूमेरिकली भी होते हैं कुछ. जैसे हमने देखा था एक्सेस गिब्स एनर्जी का एक क्वेश्चन आया था. वो सरफेस वो एरिया टेस्ट होता है थर्मोडायनेमिक कंसिस्टेंसी चेक करने के लिए. तो उस इंटीग्रेशन की वैल्यू हमेशा 0 होती है, ये फिक्स है. ठीक है, तो वहां पे भी हमें अलग से कोई कैलकुलेशन करने की नीड नहीं है. मैंने आपको सॉल्यूशन बताया था, मैंने आपको वो डेरिवेशन का एक बेसिक आइडिया दिया था किस तरह से आप कर सकते हो, आप उस वीडियो में देख सकते हो. तो अगर डायरेक्ट रिजल्ट आपको पता है कंसिस्टेंसी का, तो आपको चेक करने की जरूरत ही नहीं है कैलकुलेशन. सो सी यू गाइस, बाय बाय, टेक केयर.